Assalamu alaikum. I hope you are fine and doing well in your organic classes. Today we are going to address an important reaction in organic synthesis, which is known as Polonoski reaction. The reaction was basically discovered by two brothers, Michael and Mark Polonoski, in 1927, while working on medicinal properties of different alkalite compounds. So this is an important reaction of amines in which tertiary amine oxide are transformed into an acetyl derivative of secondary amines. They were basically alkalite chemists. And discovered the reaction while working on medicinal properties of different alkalite compounds. But before addressing the reaction, we need to focus on some important feature of amines chemistry, basically with respect to functionality of functional group. This is the functional group for amine. This is amine, in which carbon and nitrogen are linked by a double bond. Nitrogen is also linked to an alkyl group as well. This is ammonium salt. When nitrogen linked to hydroxyl groups, so such functionality is known as hydroxylamine. This is amine oxide, in which we will focus in Polonoski reaction. Basically, amine oxide can be obtained by oxidizing amine in the presence of some oxidizing agents such as hydrogen peroxide. Here we have shown tertiary amine has been oxidized by H2O2 into tertiary amine oxide. This is nitroso functionality, in which nitrogen double bond to oxygen, and this is the nitro group. We have also studied about co-elimination of well, in which tertiary amine oxide here tertiary amine oxide undergoes sort of thin elimination and gives rise to formation of alkane. So let us now focus on a general reaction of Polonoski reaction. Here we have tertiary oxide, tertiary oxide, which undergoes a sort of a rearrangement reaction in the presence of reaction vitamin hydride in pyridine coupled with DCM as a solvent for give rise to formation of an acetyl derivative of this is positive charge. This is an acetyl derivative of secondary amine along with formation of aldehyde as well. So this is a general feature in which tertiary amine oxide transform into an acetyl derivative of secondary amine. The reaction is facilitated by acetic anhydride, or it can be acetyl chloride as well. It can be acetyl chloride as well. Both acetyl chloride or acetic anhydride are used for activating the starting material, which is tertiary amine oxide. Here we have seen that the alkyl group which is linked to nitrogen atom have been removed. In other words, the reaction is demethylation as well. In the past, the reaction was excessively employed for removing methyl group. So here we also encounter the removal of a methyl group in Polonoski reaction as well. So that's why Polonoski reaction is important in demethylation as well. So now let us focus on a mechanism of Polonoski reaction, that how it transforms the starting material into a final product. Here we have tertiary amine oxide, which react with acetic anhydride. Sorry, I have for clarity, let me write it again. This is acetic anhydride. It reacts like this and gives to a complex formation, nitrogen alkyl group, positive charge, in the next step the complex rearrange and when the group release and give rise to formation of product like this. Here we have a reactive proton in which is abstracted group in the next bond rearranged like this, and another acetyl or AC group removed from the structure. Now we have got an amine type functionality. With the positive charge ion nitrogen, this is known as ammonium ion. This ammonium ion add to an acetyl group in the next step. Now we get the product like this one. In the next step, nitrogen add to another molecule of acetic anhydride. Here we have lone pair of electron, just like in the first step. Here it rearrange, and this complex ultimately rearrange. I am directly showing the two step in a single step reaction for getting a product. So what will be the ultimate product here? OAC will release this will be nitrogen R1 R, and we have added another acetyl group here. So we can rearrange this compound like this. Here we have positive charge on nitrogen atom as well. And we have acetyl group as well. This is positive charge. C double bond methyl group. This is then acetyl group. So in the last step, which is a final step and very important in getting the final product, the OAC, which acts as a nucleophile, to the complex, and we get, here I have added the OAC group, negative charge, R1, R, and E double bond, already in acetyl group. These rearrange. This arrangement is like this, and finally we get the product in which acetic anhydride is recovered. One molecule of acetic anhydride will form, plus and aldehyde will recover in the form of acetaldehyde, and here we will get R1 and R and acetyl group. So by this way we obtain in the ultimate product. This is an acetyl derivative of secondary amine. So I hope the mechanism is quite simple and you got a good grip on the mechanism. Let's revise it again. Here we are trying to react in the first step the tertiary oxide with acetic anhydride. We can also use here acetic anhydride as well. So with acetic anhydride, the difference will be if you replace this acetic anhydride with acetyl chloride. So the rest of the reaction mechanism will be same, only we will add chloride here. Here the chloride will attack this complex instead of OAC, and ultimately we get the product in which the recovered product will be acetyl chloride instead of acetic anhydride, aldehyde, and an acetyl derivative of secondary amine. So this is all about Polonoski reaction, which is very important in organic synthesis.